Assalamu alaikum warahmatullahi wabarakatuh. We are welcome back to this class today, and we want to use this video to discuss the applications of dimension. And in our previous lesson, we have learned how to write dimensions of some quantities, and it is going to benefit us to be able to recall these dimensions that we have been able to write, and also have a very good idea of indices. So what are we going to benefit at the end of this class? So at the end of this lesson, we are going to be able to recall the dimensions of some physical quantities, and we are going to be able to transform a given statement into an equation and then determine the form of the transformed equation. So these are what we are going to be able to do. So the first thing is to record. We should record that the dimension of mass is capital M in close brackets, the dimension for time is capital T in close bracket, dimension of distance is capital L in close bracket, dimension of velocity is capital Lt power minus 1 in close bracket, the dimension of acceleration is Lt power minus 2 in close bracket. So it's very important we be able to record these dimensions because they are going to be used a lot in the discussions ahead. Alright, going to the discussion, go to the second agenda, which is to be able to write equation from a given statement. We know that dimension can be used in two ways. We can use dimension to check the correctness of an equation, and also to check the form of an equation. So are the two ways in which dimensions can be used. So our discussion here is limited to checking the form of an equation. And when a statement like this is given, we should be able to write equation from this statement. But the equation we're going to write is a raw one, not the one whose form has been determined. Alright, so the question is, the period T of oscillation of simple pendulum depends on the length L and acceleration G. Determine the exact form of the independence. This is asking us to write the form of the equations. The first thing we need to do here is to write the equation from the statement, or transform the statement into an equation. And we should also note that at times the equation can be given to us, and if not given, we have to write it. So in this particular problem, it is not given, so we are meant to write the equation. And how do we write it? We are told that T depends on L and G. It means that T equals to L times G. Now what it means? It means T equals to L times G. But it's going to be L raised to power X times G raised to power Y, meaning that their powers are unknown. And it means that we are looking for their powers. So once their powers are known, we will be able to know the form of the equation, or the form of the independence. So to do this, we are going to write the dimensions of each of the parameters in the equation. And already the parameters have been defined to us. T was defined to be the period, L was defined to be length, and G was defined to be acceleration. So the dimension for T is capital T bracket, dimension for L is capital L in bracket, and dimension for acceleration is L capital LT raised power minus 2 in bracket. So we have written the dimensions of the parameters. So the next step is to substitute these dimensions into this equation. So we are going to be having T to be equal to L raised to power X times L raised to power LT raised to power minus 2 or raised to power Y. So the next step is to simplify this. And how do we simplify that? We use this power to open this bracket. So we are going to be left with T equals L raised to power X times L raised to power Y times T raised to power minus 2y. By saying minus 2 times y, you have minus 2y. Okay, and you will bring in a lot of indices. L raised to power X times L raised to power Y will be equals to L raised to power X plus Y. and times t raised to the power minus 2y. So we have t to be equals to l raised to the power x plus y times t raised to the power minus 2y. So the next step is to equate the powers of both sides, the powers of terms on both sides. And one thing we need to look at for, on the right hand side we have l and t as bases, but on the left hand side just have t. So it means that I need to bring l into this side so that you can have l and t on that side too. And how do you do that? You say l raised to the power 0, because l power 0 will give you 1 and it's still going to return this to be t. So l power 0 t raised to the power 1 equals l raised to the power x plus y times t raised to the power minus 2y. So in this case you can freely compare or equate the powers. So for power of l on the left hand side is 0, power of l on the right hand side is x plus y, and that implies that x equals to minus y. Then for t, power of t on the left hand side is 1, and power of t on the right hand side is minus 2y. If you divide both sides by 2, you have y to be equals to minus half. So we have gotten y, and if you recall from equation 1, you can see that x equals to minus y, and minus y is half. It therefore means that x is equals to half. So x equals to half, y equals to minus half. You have gotten the constants, and with this you can now get the form of the equation since the constants have been known. So what do? You now substitute the constant back in the general equation. You have t to be equals to l raised to the power x times g raised to the power y. That becomes to l raised to the power half times g raised to the power minus half, and that will be equals to t will be equals to square root of l over g. So this is derived from indices. Like I said earlier, our idea of indices must be very strong for us to understand this thing very well. Okay, going to the second example. The second example, we have that a wave is set up in a stretched string by plucking it. The velocity v of the wave depends on the tension T in the string, its length L, and mass M. In V equals kt raised to the power x, l raised to the power y, m raised to the power z, where x, y, and z are constants, and k equals to 1. Find the values of x, y, and z. Derive the expression relating v, t, l, and m. So in this particular problem, the equation have been given to you, so it makes the work very simple because you have the equation, you are no longer writing the equation. But if I told you had to write the equation, let's this one was not given, you just say v depends on t, l, m. That would then be v equals to t raised to the power x times l raised to the power y times m raised to the power z, and that is what we have here. Okay, so that is how we have written it, but now it's given. Let's go straight. The next step to write the dimensions of the parameters in the equation. We have defined the parameters that v is velocity. Dimension of velocity is l to the power minus 1, and the k is constant, so k is 1, and dimension of constant is 0. Let me say constant has no dimension, so you delete it. Dimension of t is given to be tension. Tension is an example of a force, and dimension of a force is ml to the power minus 2 or raised to the power x times dimension of l is capital L raised to the power y. Dimension of m is capital M raised to the power z. Alright, so it's simplified further by opening the bracket. X, you use power x to put the bracket, that will be m power x times l power x times minus 2 times x, that is t to the power minus 2x dot l power y dot m power z. Okay, then you break indices in. M power x times m power z will be m power x plus z times l power x times l power y equals to l power x plus y times t raised to the power minus 2x. Alright, it's simplified. The next step is to now compare the powers or equate the powers. And don't forget that before equating the powers, the number of parameters on the right hand side must be equal to the number of parameters on the left hand side. You can see on the right you have MLT, but you only have L and T here, so you need to bring M here by saying M power 0, so I can have M on both sides, and that is going to be M power 0, L is power 1, T is power minus 1 equals M is power X plus Z times S power X plus Y times T is power minus 2X. So we have the powers on the basis, then we start with M. For power of M on the left hand side to be 0, but on right hand side to be X plus Y. So X plus Z, excuse me, and that implies that X equals to minus Z or Z equals to minus X, case may be. Then for L, power of L on the right and left hand side is 1, and for the left hand side is X plus Y, equation 2, equation 3. For T, power of T on the left hand side is minus 1, power of T on the right hand side is minus 2X. We have both sides by minus 2, implies that X equals to half. So we have gotten X to be half. We can equally get Z. Z is going to be minus half if X is half. Alright, so but before that, from equation 2, we have Y to be equals to 1 minus X. Since X is half, Y will be 1 minus half and Y is equals to half. And from equation 1, X equals to minus Z. So X equals to X equals to minus Z and T is equals to minus X. Since X is half, Z is going to be minus half. So we should understand that using indices. And since we've gotten the constant X, Y, Z, we then substitute it into the general equation. The equation initially we were asked to look for X, Y, and Z, which we have done. That is equation 1. Equation 2 says we should find the form of the equation. And for us to get the form of the equation means that we have known the constants. So the constants are known. We substitute into the equation. We have V is equals to K, T raised to power half times L raised to power half because Y is half here times M raised to power minus half, Z is half equal, and K is 1. So if K is 1, you just put K here, and you're going to have V to be equals to T times square root of T times L divided by M, because power half on each means square root, then T times L. This negative brings this one to be denominator, to be divided to be T L divided by M. So the general form of the equation is going to be V equals square root of T L over M, and that is all. So quickly going through the procedures. 1, you get the equation if not given, but if given you use it directly. And 2, you write the dimensions of the parameters on the equation. Then you substitute the parameters back into the equation so that you can be able to equate the powers on both sides, or the parameters on both sides, and you can get the constants. Once the constants are known, then you have gotten the form of the equation. You need to substitute the constants back into the general equation, and then use indices right there and get the form of the equation. Thank you so much for your audience. Assalamu alaikum wa rahmatullahi wa barakatuh.